guys, let's begin with the problem sum of subarray minimum. So let's first try to understand the problem statement. So given an array of integer ARR, find the sum of mean B, where B range over every contiguous subarray of ARR. Since the answer may be large, return the answer modulo. Okay. So let's try to understand the problem statement by example 1. So this is the given array and we need to find the minimum of all the possible subarray. As you see here, it is written in the explanation part. This is all the subarray, possible subarray of this array, and take the minimum of all the subarray and just add and return the answer. As you see here, for this minimum is 3, for this 1, 2, 4, 3 and 1. Minimum of 3 and 1 is 1, minimum of 1 and 2 is 1, minimum of 2 and 4 is 2, and minimum of this is 1. Okay, so I hope you got the problem statement. Okay, so to solve this, the prerequisite for this problem is that nearest smaller element. So I will talk about it later on. What is this? If you know, then it's good for you. If you don't know, then don't worry. Okay. So first of all, observe the pattern, how it is happening, like what we need to find out. If you observe it, like if we find out all the possible subarray and then find out the minimum, so it will take n square in finding all the subarray and just finding minimum. Okay, it's n square. The brute force approach, that is n square it will take, but the value of n is 3 into 10 to the power 4, so we are not allowed to use n square. Okay, so how we can optimize it? So if you observe one thing carefully, you will find out that for each element which contributing to the answer, for all the possible subarrays which are to the left, those numbers which are greater than the current element, and similarly for the right part also. Let's understand what I say now. What I said now. Okay, let's see. So let's see this for the 1, for this element 1. So if I see the nearest smaller left element, 3 is greater, means that there is no one in the left side that is smaller than 1. And in the same way for right side also, it means that all the possible subarray that I can able to make or form by using this element 1. So in those all the subarray, my answer is 1, because each time I will take minimum of all the elements, and that will I get is 1. As you see here also, 1, 3, 1 is the another subarray, 1, 2 is the another subarray, 3, 1, 2 is the another subarray, 1, 2, 4 is the another subarray, and 3, 1, 2, 4 is the another subarray. So it means that I have to find out total number of subarray in which this 1 is the part, 1 is the element of that subarray. So how to frame, how to make? So I told you earlier, just find out the nearest smaller left element and nearest smaller right element, the indexes. Let's say here is no one, so just -1. As you see here, for the element 1, I have find out the nearest left element, that I assign it as a -1. And the same way, right element, also there is no one in the right side that is smaller than 1. So I just assign it as a 4, because 3 is the last index. It means that 4 is assigning to the last to last element. Means there is no one that is smaller than 1 current element. So in the same way, each time I am finding the nearest smaller left element for the current element and nearest smaller right element for the current element. As you see here, for this index 3, for this element 3, that index is 0. So there is no one in the left side that is smaller than. So just I assign it as a -1 because its index is 0. So the leftmost part is -1, and the greatest element, the smaller element that is nearest smaller right side. So 1 is the smaller and that is nearest also in the right side. So as you see, right equals to 1. So basically it's denoting that the index of the nearest right element. So in the same way, I have find it out for the 1, as you see, -1 and 4. For 2 also, 1 is the nearest leftmost element. So that's why I assign it as a 1, and for 2 there is no one in the right that is smaller than the 2, so I assign it as a 4. So in the same way, for each of the element I find out nearest left and nearest right. Okay, so now question arise here. I find it out like in this example, as you see here, this one making total number of this one is the part of the total number of 6 subarrays. So how to find it out? So I have to build how many subarrays I can build by using this one. So basically just find it out total number of elements that is present in the left side including this one, multiply by total number of elements present in the right side including this one. So here it's 2 and this side it's 3. So 3 into 6, it means that this 1 is the part of the total number 6 subarrays. 3 into 2 is 6. As you see here, this one 1, 2, 3, 4, 5 and 6. So in this way I have find out the left gap. Left gap is means just index minus left index, the left smaller index that I have calculated already here. So this is the left gap for each element, and for the right gap just find it out by just n minus n minus right I index minus right I minus index. So right smaller index element whose index that I already stored here 1, and just subtract the index, the current index. So as you see here, the right gap I got is 1. So total number of subarray for which 3 is the part of the answer, that is left gap into right gap, that is 1 into 1, that is 1. So you can see here 3. So 3 is also coming only one time in the answer. In the same way for 1, 3 into 2, 6, and we have already seen here for the 6 subarray how it's giving. For 2, 2 into 1, it means that 2 subarrays are there, as you see here 2 and 2. So from this is one subarray, sorry not this, this is the one subarray where 2 is the part of the answer, and the another one is this one 2 4. And for the 4, 4 is only the part of 1, 1 into 1, that is 1, and just multiply with the current element, that is 1 into 1 into 4. So that's why 4 I am adding 4 in my answer. In the same way, just left gap, right gap and into current element. So 3 6 4, just add it all and the 17 is the answer. In this way I am getting 17. But yes, there is now how to find it out, the left nearest smaller element and the right nearest smaller element. So I told you like it is already a prerequisite for this problem, and we can find it out by using a monotonic stack. So let's see like how we means how I will try to find it out. That's for each time I will insert the element in the stack in such a way so that my stack will remain in a ascending order or in descending order as per the choice, as per the requirement. Like here I want to find out the nearest smaller element, so I will insert the elements in the ascending order, sorry, in the increasing order from smaller to greater one. So let's see, to get the more clarity for this problem, just be with me. I will explain you by writing the code, and I will also explain this one case when the duplicates are present. Then in that way, how to remove the duplicate elements, how to remove the duplicate subarrays. Okay, so let's see. So first of all, I need to find it out the nearest smaller left and the nearest smaller right. So just take a vector int and just left. Okay, here are dot size. Okay, just store it int n equals to here are dot size. Okay, n, and just I am assigning it as a -1. If no one in the left side that is smaller than, so in that case -1 I will assign it with -1, that's why. And for the right, just n comma n. So now find it out. Okay, So to find out the nearest left smaller and right, I need a stack. So let's consider this stack st. Okay, okay, so just put one case. If st dot empty, if stack is not empty, and so first check before inserting it, first check the order of the stack. So st so I am inserting index in the stack, so st dot top will give me the index. So if it is arr dot I, it means that the current element. So if the element that is inserted at the top is greater than the current element, so in this condition I will remove, because I want to insert the elements in increasing order in the stack. So just remove it, st dot pop. That's all. Now if st dot empty, just check if stack is empty. So if stack is not empty, if stack is not empty, then this condition will run, and just store this left. So left I equals to st dot top index, and at the last just insert st dot push I. That's all. So st dot empty. Okay, so in this way we will get our the nearest left part. Now it's time to find it out the nearest right. So for the nearest right, just start iterating from the last element up to index 0, and also first of all we need to empty the stack. So st dot empty, just pop out all the elements if any element is present in the stack. Okay, now my stack is empty, and that's all, like right. Okay, so I think, yeah, so in this way we will get our right nearest elements also. Now so int answer equals to 0 and mod, so mod equals to 1e9 plus 7. Now just calculate it for the each of the element. So as we discussed here, just find out the left gap and right gap and just multiply all left gap right gap into current element. So how to find it out left gap and right gap? Just see, left gap equals to, so I minus left I. Also same way right gap, so right gap equals to right I minus I, and answer equals to answer plus just converting it into the long, and then left gap multiply by right gap and multiply by current element, that is error I. Take mod and take again one mod to avoid overflow. Okay, and at the last just return the answer. Okay, but just wait. I told you about the one test when the elements have duplicates present. So what to do in that case? As you see here, so for to avoid the duplicate, like if I find it out the for this element, for this 55, for the first 55 for the index 1, so this 55 74 55, this subarray will come twice when I calculate it. So this when I will calculate it for this element, so this is the right subpart subarray, and for this element this is the left subpart subarray. So to avoid this case, just put a one equality sign in any one of it. as your wish, like you can put here also and you can put here also, and just only one place, and just remove it. So let me run. Okay, so the test cases are passing, so let me submit it. Okay, so as you see, the solution get accepted. I hope the solution is clear to you. If you don't get this part, how I'm calculating the nearest left smaller element and the nearest right smaller element, so just try to first solve that problem and then come to this problem, so that you can solve it by yourself. That's all for this problem.